In this Let's Pi series, we'll be looking at how to create some small projects using the GPIO pins on the Raspberry Pi. We'll start out simple using some basic LEDs, push buttons and resistors, and later on integrate a basic LCD display. With this LCD display, we'll look at printing some simple messages, and then later on look at how we can integrate it with our Twitter accounts. What I have in mind for this is an LED flash to notify you of a tweet. We push a button on the breadboard to read it, and the message will appear on the LCD screen. Another simple tutorial we'll do early on in Let's Pi is a simple game using one push button. The game will be coded in Python using a module Pygame. Don't worry if you've not heard of it, we'll cover it later on. But in a nutshell, the game will consist of a ball that you must keep in the air using the push button. The main reason why I started making YouTube videos is to learn how to develop for the Pi and share my learning experience with you all. The book I have picked up to kickstart my journey is the Francis Raspberry Pi Maker Kit. Coincidentally, this is where the hardware components for the following few tutorials have been sourced, and I picked up this kit for around £45 at a Maplin store, which is a popular electronics store in the UK. Although if you're just following along and you have your Pi already, you can buy the components dirt cheap at online stores such as RS Components and Farnell. A link to both of these in the description. If you intend to set up the same examples as these videos, you need to get your hands on the following components: breadboards, LEDs, push buttons, resistors, and a single LCD display. Breadboards are used to quickly connect our circuits and easily exchange components without the need to solder. You can see here an example of the breadboard. The horizontal dots are connected, with the exception of the gap which splits the horizontal sections into two. The vertical dots are also connected in a similar fashion. LEDs consist of two legs, one longer than the other. The longest leg is called the anode, and this represents the positive connection. The shortest leg is known as the cathode, and represents the negative connection. As current flows from positive to negative, it does matter which way around you connect an LED in your circuit. The push buttons provided with the Francis kit have four legs just like the one you see on screen. The opposite legs are connected when the button is left alone, thus creating an open circuit, and all four legs get connected when the button is held down. We will learn how this can be used to read input from the button later on in the series. Resistors are simply used to provide resistance to the current so we don't overpower our components. For example, if you plug an LED straight into the power outlet, or even with a resistor which doesn't provide enough resistance, you can blow the LED. Resistance is measured in ohms, and you can use the following table to match the stripes on the resistor to the required resistance. For example, if you want a resistor with 220 ohms resistance, we will pick the red, brown resistor, with the fourth stripe having little to no relevance to us. The Francis kit comes with a 2-line LCD display, which if you don't have the Francis kit you could also pick up fairly cheap online.